In this video, I'm going to show you how to assign oxidation numbers for very simple compounds that use only rules 1 and 2. Now, when you're assigning oxidation numbers, the key is to know these 6 rules. You should memorize these. And you've got to apply them in order. So you should know that the first thing you check is whether or not you've got only one element. If you do, you've got an oxidation number of 0. Now, if you've got an ionic compound with elemental ions, those are ions that you can look up on the periodic table, then you can take the charge of those ions as the oxidation number. The other rules we'll talk about in the next video. Let's do some examples where you're using just rules 1 and 2 to keep things simple. Okay, suppose I throw this at you. This is a form of the element phosphorus. You get 4 phosphorus atoms linked together. And I ask you then, what's the oxidation number on the phosphorus? Well, you look at rule 1 and it says, do you have only one element in this thing? You do. All you've got is phosphorus. Then the oxidation number is going to be 0. Okay? So what if I've got sulfur, which comes in little necklaces of 8 sulfur atoms? And I ask you, what's the oxidation number on each sulfur atom in there? Well, again, rule 1 tells me I've got only one element, so they're all going to have an oxidation number of 0. Now, when I write this isn't an oxidation number of 0 for the whole thing. It's an oxidation number of 0 for each atom that is in my formula. So all 8 of those have an oxidation number of 0. All 4 of these have an oxidation number of 0. Okay, let's do one where we've got to go down to rule 2. Let's start out with a real simple familiar one. Suppose I give you NaCl. All right, well then you know from looking at a periodic table that what you've got here is a ionic compound. The sodium is a metal and the chlorine is a nonmetal. You look on either side of that staircase that goes between boron and aluminum, and anything to the left is a metal and anything to the right is a nonmetal. So I've got an ionic compound here, and further I can look at which column these elements are in. The sodium is in the first column, where the alkali metal column, where I know everything forms +1 ions. So what I have in there is a sodium ion that looks like this. It's got a +1 charge, so I'll say the oxidation number there is +1. Now, if I look at the chlorine, look at the periodic table. It's in the halogen column. What's the charge on all the ions for everything in the halogen column? It's a -1. So that ion that you have in there is Cl-. And I can say that since the charge on this is a -1, I've got a -1 oxidation number. So the oxidation number for simple ionic compounds like this is the same as the charge on the elemental ions. Now, when I say the word elemental ion, I'm talking about an ion that contains only one element. Now, we're going to see a little bit later that there are some ions that can have more than one element. Let's do one that's a little bit more complicated than that. Let's do this. All right, now I look at the periodic table and I notice that this is a metal, potassium, and this is a nonmetal, sulfur. So this is going to be an ionic compound. And I can tell from the columns that the elements are in what the charges on all of the ions are as well. Potassium is in the alkali metal column, and everything in that column has got a +1 charge. So I know that there are potassium ions in there. Now, there are 2 of them. See, this doesn't really affect the charge. It's where the element is on the periodic table that determines the charge. So I have 2 K+ in there. Each one is going to have an oxidation number of +1, because that's what the charge on this thing is. Now, if you look at the sulfur, it is in the same column as oxygen, and everything in that column has an ionic charge of -2 when it forms ions. So I know the charge on that will be -2. So I know that the oxidation number on the sulfur will be -2. Now, one way you can double check this is to sneak a look at Rule 3 here. It says that all of your oxidation numbers have to add up to the total charge. Now, your total charge on this thing is 0. So the oxidation numbers for all of the atoms have got to add up to 0. So I have 2 potassiums, that's a +1 and a +1, and then I have a sulfur, and that's got an oxidation number of -2. If I add these all up, they all add up to 0. So I can be confident that, a little more confident, that I assigned all the oxidation numbers correctly in something by seeing whether or not they all add up to the total charge on the formula that I was given. Now let's try one that's a little bit harder. Let's do one of the ones that appears in the sparkler reactions in the lecture slides. Okay, this is an oxide of iron. Now if I look at the periodic table, I can clearly see that iron is a metal and oxygen is a nonmetal. So what I got here is an ionic compound, and it's going to contain an elemental ion that's iron and an elemental ion that's oxygen. Now the trouble is, if I try to look at which column the iron is on the periodic table, the iron is in the transition metal section of the periodic table, and you cannot tell what the ion charges are for any of the transition metal ions. You can't tell from the periodic table. So you're kind of out of luck if your metal is in the transition metals, or if it's in the actinides or the lanthanides. You have the same kind of trouble. But that doesn't mean that you can't find out what the charge on that iron is. We're going to look at where the oxygen is. The oxygen is in the column that has -2 charges. So each of those is going to have a -2 charge. You're going to have an O-2, an O-2, and an O-2. Why did I write it down 3 times? Because there's 3 of them in the formula. Each one has got a -2 charge, and so a -2 oxidation number. Now, the total of those 3 is -6. And for this whole thing to stay neutral, I've got to have the total for both of the irons be a +6. So whatever the charge is on each iron, they both have to add up to be +6. Now there's 2 of them. There's no reason why one of them should be different from the other. They'll both be the same. So if I say that if they have to add up to +6 and they both have to be the same, that means that I can put a +3 on those. Now notice how everything works out. When you add up the oxidation numbers for all of these, they all add up to 0, which is the overall charge of this. +3, +3, -2, -2, -2, all add up to 0. So I did this right. So I would say each iron has got an oxidation number of +3, and each oxygen has got an oxidation number of -2. All right, in the next video, we will do a few more complicated examples that require us to use some of the other rules.